As mentioned in previous videos, the EEROS control system consists of blocks, signals and time domains. In this video, I will introduce you to blocks. I will also show you how to assign blocks to time domains using the executor and how to group them into subsystems. Let's take a closer look to the EEROS blocks. A block can have several inputs and outputs which carry signals. These signals are transformed or modified from input to output by the algorithm of the block. The algorithm of a block is coded in the run method, which is activated with the clock of the time domain. Blocks can be configured with parameters. For example, for a game, the parameter would be the factor by which the input would be multiplied. The example shown on the right is an integrator block. It is often used to build PID controllers or to realize observers. Sometimes you also want to save values and use them the next time the algorithm is called. In the case of the integrator, this is the integrator's internal value. Blocks can also have methods that are called by the sequencer of the safety system. With the integrator, for example, one wants to set the initial values or stop and restart the integration. This is very important because the integrator in a controller is not allowed to integrate when the motors are switched off. Let's talk about how to connect blocks with signals. Every output carries a signal. An input can connect to an output. The signal connection is created backwards. Any number of inputs can be connected to one single output. On the other hand, only one output can be connected to one input so that it is always clear where the signal is coming from. This prevents the user of EEROS from accidentally sending contradictory signals to the block. As already mentioned, standard blocks change one or more signals and belong to exactly one time domain that controls the execution of the algorithm. Typical input blocks are simple sensor interfaces such as encoder inputs and analog or digital inputs, but also complex inputs such as those of multi-beam laser scanners. Output blocks are analog or digital outputs, but also complex outputs such as connections to servo drives via CAN or EtherCAT. Instead of connecting inputs and outputs to real hardware, they can also be connected to simulation models. Transition blocks are for transferring signals from one time domain to the other while keeping the time constraints in mind. Since they are called from two different time domains, they must also have two run methods. Typical applications are filters or interpolators. In the example on the left, you can see a transition block where a slow signal goes in and a fast signal comes out. This could be, for example, a camera input that provides an absolute position estimation every 20 milliseconds. This measured value must be interpolated so that it can be combined with the measured value of an acceleration sensor by means of sensor fusion, resulting in a high-frequency position estimate. The example on the right shows a transition block from fast to slow. Often only the last measured value is used, but it makes sense to use the high number of input values to filter and smooth the signal. In many cases, filtering should also be used so as not to violate the Nyquist-Shannon sampling theorem. Each signal carries a mandatory timestamp. A signal source, such as a trajectory planner, defines a value over time and therefore sets the timestamp corresponding to the generated signal. Blocks that read from an external source set their timestamp to the time the value was captured. Simple time-invariant linear operations such as multiplying by a constant do not affect the timestamp. However, blocks which depend on a sampling time, such as integrators or differentiators, will change the timestamp according to their inner algorithm. A differentiator, for example, delays the timestamp by half of a control cycle. If calculations are performed with several signals, the signals should be based on the same time base and have the same timestamps. Therefore, it may be useful to convert the values of the incoming signals to a common time base before calculating the algorithm of the block. Transition blocks have a clear influence on the timestamp. Let's look at a transition block from fast to slow. If, in the simplest case, only the most recent signal value is used, the timestamp of this value can be copied. However, if a filter is implemented, the signal is delayed by the time constant of the filter. In the case of a transition block from slow to fast, a new individual timestamp has to be calculated for each output value. As earlier already covered, each block belongs to a time domain that determines the frequency of execution of the block's run method. The order of execution of blocks within a time domain is determined by the order of which the blocks are added to the time domain. Care must be taken to ensure that the calls follow the signal progression, resulting in the most optimal time sequence with minimal dead time. Above all, it must be ensured that all signals presented at the input of a block have been updated before the block is calculated. Closed loops must be split at one point. The value of the signal is stored and passed on with the next call on the time domain delayed by one cycle. If necessary, the timestamp must be adjusted at this point. Complex control systems can consist of many different subsystems, such as observers or kinematic and dynamic models. In order to represent these systems elegantly and clearly, one can define subsystems in the EEROS and thus create a block that contains other blocks and signals. As a next step, go to the wiki.eeros.org website. Read the sections Blocks, Executor and Subsystems on the Control System page. A lot of useful blocks already exist, so you should also read Available Blocks. Take a quick look at custom blocks. You won't need this anytime soon because you will mainly work with existing blocks. If you have any questions, please ask them in the forum on the Moodle. Learn about the next steps in Moodle and watch the video on implementing the control system. Thank you very much for your interest.